Good afternoon, dear students. Good afternoon. Good afternoon. Good afternoon, dear students. Chalo, bhai, come on, join the session very fast. Welcome to the Gradeup. Welcome to the Gradeup, the India's largest e-learning platform, dear students. Come on, join the session very fast. आ जाओ भाई सब. So this is the marathon session, dear students. Actually, we plan for the production engineering. In production engineering, this is the topic we have taken for the discussion: metal forming, isn't it? Am I audible and visible, please? So have some movement in the chat box. Amresh, very good afternoon, dear. Amresh, very good afternoon. Please show me your presence in the chat box. Show me your presence in the chat box. And dear students, please share this link, share this session amongst your students, friends, so that they can also join. So come on, join very fast. Join the session very fast. So dear students, this is the leftover part of the session, metal forming. Yesterday we have started this series, dear students, this marathon session. Yesterday we had talked about very important fundamentals or some fundamental things about the metal forming. Okay, or fundamentals of metal forming we have covered, and in the today's session हम क्या देखेंगे? हम देखेंगे bulk deformation processes. So be there, be there. Am I audible and visible? Yes. So shall we begin? Shall we begin? Mark your response, dear students, in the chat box. Am I audible and visible? And shall we start for the today's session? Shall we start for the today's session? Please let me know. Let me know. भाई आ गए सब लोग. चलो जल्दी से ज्वाइन कर लो सेशन को. This is about me, dear students. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. Till now, I have mentored more than 10,000 number of students. My area of expertise are production and industrial engineering, fluid mechanics, mechatronics, and robotics all as well. Akhilesh, yesterday in between you left, I hope. Then Imran Khan. So attend, dear students. Please join the session very fast. Join the session. Be present there in the huge numbers, students, please, so that I will start the session. So dear students, yesterday the fundamentals, I hope the fundamentals of metalworking is now clear to you. See, fundamentals of metalworking is clear to you, starting from the simple stress, strain, that is the nominal engineering stress strain, then the true or instantaneous stress strain, what is the relationship between them, then in the plastic deformation zone, which law is valid? We know that law, the Flocker equation we have written, sigma t is equal to k into epsilon to the power n. Then we also talk about the flow stresses, which is the instantaneous stress, right, with which the liquid, the material can be flow like a liquid because the application of the huge amount of compressive stress. That average flow stress, very importantly, I yesterday told you that average flow stress, dear students, plays very important role when we are go for calculation of the load in the bulk deformation processes. For the load calculation, for that point of view, dear students, this flow stress is very important. Okay, then also we discussed about the various how to calculate the work done, how to calculate the work done in the deformation zone, which is nothing but equal to k into epsilon f to the power n divided by n plus 1, which is the actually work done per unit of volume. Okay, and if you want the work done in newton meter or work done in, see, all are available on Kiran. All the things are available on YouTube. Okay. So you will get all the things here only on the YouTube channel only. This is available. So like that, yesterday we have seen all the things. Fundamentals. I hope it is clear. Fundamentals with required number of numericals. We try to understand the concept as well as how they are asking the numericals. Definitely, I hope हमने जो भी कल देखा है सही से देखा है. Right now, this is the time to go for the processes, bulk deformation processes. And very importantly, dear students, जैसा मैंने कल भी बात किया था कि भाई रोलिंग अगर आप previous years question papers आप देखोगे, definitely will come to understand, come to know that yes, there are so many chances to have the numerical from the rolling process. Okay, so definitely we are going to discuss the rolling process first. Okay, not the entire process, but which are the very important formulas that we need to solve the questions, right? This formula, I hope yesterday also we have already seen those formulas for the rolling process, right? And yes, today also I will just put the formulas first and then we will go on solving the question. So this is the question in front of you, dear students, right? So the question says that in a single pass rolling operation, a 10 millimeter thick plate with the plate width 120 mm is reduced to 6 millimeter thick. Okay, thickness is reduced to 6 millimeter and the width of the strip is 120 millimeter. The roller radius is given as 200 millimeter and the speed of that roller is given as 20 rpm. Okay, Kiran, class 8 about metrology and inspection. Dear students, today also on the gate this Gradeup free app, there was the session on the welding technology, fabrication. Okay, so please, dear students, there also some of the very nice series are running. So try to attend that series, right? I will share you the link, Kiran. So shall we begin? So see, this is the question, average flow stress of the sea. Now you can see, understand. Average flow stress, right? Average flow stress, right? Sigma flow, average. The same thing. Yesterday we discussed about this. Same thing. That is sigma flow, okay, into epsilon F. Okay, average work done we have taken over the work done. That is K epsilon F to the power n plus 1 divided by n plus 1. So again, this flow stress, average flow stress into epsilon F is equal to K strength coefficient into, if I expand this, that is epsilon F to the power n into epsilon F, isn't it, divided by n plus 1. So देखो epsilon F will get cancelled out and you will get this flow stress average, which is equal to K into epsilon F to the power n divided by n plus 1. Okay, so see, try to understand. So whenever the flow stress is directly given, there is no any extra work that you have to do. Nothing is required. Just you take the value and use it as it is in the formulas. But dear students, the material is strain hardened material. So if they given some of the information regarding to the strain hardening exponent, some of the information regarding to the strength coefficient, right? In that manner, or in that case, in that situation, definitely you can calculate the flow stress with this formula, and then use that stress into the equations. Directly you can get the value. Now see, yesterday we already discussed about the rolling process. Which are the formulas we have written? H original is the initial thickness of the plate. H final is the final thickness of the plate. B is the width of the plate. Okay, B क्या है? Width of the plate. Width of plate. Then dear students, the alpha क्या है? It is a bite angle. Okay, bite angle, the angle of deformation. Okay, with the center of the roller, the angle subtended by the deformation zone up to the center of the roller, which is the bite angle alpha. Then dear students, also we have seen the delta H max is what? This is the maximum possible reduction or maximum possible draft, which can be written as mu square r. Also we can have LP, which is the length of arc of contact if these are the rollers. So definitely dear students, see, okay, so this distance is nothing but our LP, length of arc of contact. Say this angle, okay, this angle you know very well, this is the angle alpha. Okay, bite angle. If this is the r is what? The radius of the roller, right? LP is equal to what? It is nothing but root over r times delta h, r times delta h, isn't it? You know all this formula, but still I am writing. Then how to write the draft? Delta h is equal to 2r into bracket 1 minus cos alpha, 1 minus cos alpha. Then how to calculate the force? You know, force is equal to roll separating force. Roll separating force we can say, which is equal to, if we are assuming that the plane strain condition is valid, then this 2 by root 3 sigma y, or sigma y can be replaced by the flow stress into B times LP, B times LP into bracket 1 plus mu LP divided by 4H average, 4H average. H average is the average thickness, H original plus H final divided by 2. Mu is the coefficient of friction between the roller and the plate or the strip. We can able to calculate this force like this. And then anybody ask you to calculate power, you know it is equal to total power. When I say it is, there are the two rollers, okay, into T omega. So which will be 2 into roll separating force. Okay, torque is what? Force into distance, that is the arm movement, which is equal to force into arm movement into omega. Okay, force you know, 2 into 2 by root 3 sigma y BLP into bracket 1 plus mu times LP divided by 4H average. Okay, and what is this R moment? See, when we are considering this force, say this is the plastic deformation zone from here to here. So we are really having this force, the resultant force, say, acting like this. Okay, so this distance is nothing but this R moment lambda times LP. Okay, so some fraction of the LP we are having that moment length. So definitely this is R moment lambda, this is R factor lambda into LP into omega. And you know lambda is 0.3, R factor which is 0.3 for the cold rolling, and it is 0.4 for lambda is 0.4 for hot rolling. You know very well. Okay, so I yesterday I told you, unless and otherwise it is stated, in the question or it is mentioned, you have to take the rolling operation is as a hot rolling operation, isn't it? Right? So these are the formulas, dear students. Omega, we know omega is equal to what? 2 pi n by 60. You put the values there and you will get the total power in terms of what. Okay, so in the given question, dear students, in the given question, see, in a single pass rolling operation, a 10 mm thick, try to calculate, chalo calculate karo bhai, aur calculators le lo haath mein. In a single pass rolling operation, a 10 mm thick plate with the plate width, so 10 mm, H original is how much? 10 mm, H final is how much? 6 mm. Okay, B is how much? 120 mm. Okay, then what is given? Width is given. Okay, 120 mm. Radius of roller is given. Radius of roller R is equal to 200, and the rotation N is equal to 20 revolution per minute. It is given, right? Then the average flow stress of the material is how much? 320 average flow stress, sigma flow average, which is equal to 320 megapascal Newton per mm square. Right? I hope it is clear. All the things I have written now. Now the thing is that to calculate the roll separating force, I need to calculate what? The coefficient of friction. So delta H max, I know how to calculate it, is equal to mu square times R. Okay, mu square, mu is unknown, R is how much? 200, and delta H is maximum how much? 10 minus 6. So tell me what is the coefficient of friction mu? That will be 4 divided by 200 root over answer. It will be 0.14. Shall I take this 0.14 as a coefficient of friction? Okay, okay. चलो भाई ले लो सब कैलकुलेटर साथ में ले लो and try to have the calculations. Now go on calculation of the force. Roll separating force first. Roll separating force 2 by root 3 sigma y or sigma flow into B times LP into bracket 1 plus mu times LP divided by 4H average. Okay, so be there. Yes, tell me the value of RSF, roll separating force. Roll separating force is equal to 2 by root 3. Sigma flow is given 320. I hope it is clear. 320 is given. Okay. Then B into LP. B is how much? 120. B is 120 into LP is what? Under root R delta H. R is how much? 200 into delta H. 10 minus 6. It is 4. Okay. Into bracket 1 plus mu is how much? 0.14 into root over LP is what? Root over 800 divided by 4 into H average. H average is how much? H average is how much? Initial thickness 10, final thickness 6. So 10 plus 6, 16 divided by 2. That will be 8 millimeter. Calculate this force and tell me. I'm not going to do the I'm not going to have the calculation by my own. Please, you are telling me the value. Tell me how much is the force? Please calculate. How much it is? Yes, Nikhil, Akhilesh, Imran, Amresh, Kiran, what is the value of roll separating force? Force F is equal to how much? Is it 1403.6 kilonewton? Please check it out. Please check it out. Is this the force you are getting here? Yes, dear students. Do the calculations. Okay, 1409. 1409. Okay. Okay, fine. So once you get this force, now what is that? Arm movement, which is lambda times LP. So it is nothing is mentioned about the which is the rolling operation, whether it is cold or hot, unless and otherwise stated. Okay, by default you have to take it as a hot rolling operation. It will be lambda 0.4 into LP is how much? Root over 800. Okay, root over 800 into 0.4. So it is 11.31 millimeter. Okay, 11.31 millimeter. Okay, isn't it? And omega is what? 2 pi n divided by 60. So 2 pi into RPM is how much? 20 divided by 60. Isn't it? So how much it is? So it is omega is nothing but 2.1 radian per second. Right? 2.1. So everything we have calculated. Now just put the values in the power formula. So power is equal to what? Total power I am calculating. Total power is nothing but 2 times roll separating force, okay, into moment R, okay, force into distance, this is nothing but the torque, okay, okay, and into omega. So tell me 2 into roll separating force is how much? 1403 kilonewton into 10 to the power 3 into what is LP? LP is how much? Length of arc of contact 11.31 millimeter. So I am calculating the power, so definitely I have to take this distance in terms of meter into 10 to the power minus 3 into omega is how much? Omega 2.1. Omega 2.1 radian per second. Then tell me what is the power, total power, P total, tell me. So how much it is? 1403 into 2 into 11.31 into 2.1. So tell me how much it is? It is coming as 66 kilowatt. Total power, how much it is coming? Please, 66.64 kilowatt. Check it out. Is that okay? Calculations are okay? Whether the calculations that we have done is correct? So that is correct, no? So 66 actually the answer. How much total power is coming? I hope anyone else other than Lakshman who is calculating correctly, please. Akhilesh, Kiran. So I hope it is clear, or any mistake that we have done, please check it out. I hope it is clear. If any mistake, please let me know. Highlight that mistake. I hope the answer is correct. 66 kilowatt, 66. So all the things we have taken it correctly. अरे भाई रिस्पॉन्स दो कुछ तो. Come on, dear students. I hope it is clear. If any mistake, then tell me. I hope we have done it correctly, so that will be the correct answer. Okay. So force we have calculated. I hope force is correct. Right, 14, that is 1.403 meganewton was force was there. Arm factor we have taken as, unless and until it is stated, we have taken as hot rolling operation. Okay. Right. Okay, fine. Take the next question. Take the next question. Yes, in a single pass rolling process using 320 mm diameter steel roller, a strip of width 180 mm. Okay, so single pass rolling process is there using the diameter of the roll is 320 mm. 320 mm. A strip width is there. B, how much it is? 180 millimeter. And thickness of the strip is how much? Thickness of the strip H original is how much? 6 millimeter. Okay, undergoes 25% reduction of the thickness, 25%, that is H final will be how much? 0.75 times this 6, how much it is? 0.75 times 6, how much it is? 4.5. Is it 4.5 mm? Okay, it is 4.5 mm, final thickness 4.5 mm. The angle of bite in radian, the angle of bite in the radian, please tell me value angle of bite in the radian, dear students. If you calculate how much it is angle of bite, that is the angle of deformation. So we know that this 2r into bracket 1 minus cos alpha, which is nothing but the draft delta h. Okay, so 2r nothing but what? 2 are nothing but what? The diameter of the roller is how much? 320. So 320 into bracket 1 minus cos of unknown angle, this alpha, is equal to delta is how much? This 6 original, 4.5 final. So it will be how much? 6 minus 4.5. It will be 1.5. And then calculate. Very easy, calculate. So 1.5 divided by 320. Okay, and if we calculate like this, 1 minus answer, shift cos inverse of answer, so it will be 5 point, alpha is coming as 5.54 degree. So 5.54 degrees, but they are asking in the radian, so multiplied by pi divided by 180, how much it is? 0.0968, 0.09686. Yes, that is the answer, which is equal to 0.09686. This is in radians. Okay, this angle alpha. Yes, I hope it is clear. So this is the simple calculation for the bite angle, calculation of the bite angle. Once you know the formula, dear students, this is the formula you can use there, and very easily you can able to calculate the bite angle. So this is this type of question you can find in the gate for 2 marks, right? Yes, Akhilesh, very good. D Delhi 0.0968, 0.09686. I hope Akhilesh, D is the answer. 0.0968. Okay, so let us go for solving the next question. Next question, of course, this is on the wire drawing operation. Okay, take the question on the wire drawing operation, dear students. So if I give you the sum of the background of the wire drawing operation, see, wire drawing operation, so there is a die, you know very well. Okay, so input is as a rod, okay, circular cross section of course, and output, dear students, it is coming as a wire, you know very well. And we are pulling this wire, dear students, and we are winding of this wire on the roll. Okay, this pulling force is there, force of course in the wire drawing operation, it is nothing but the drawing stress into final area, right? So of course this is the cone angle, dear students, okay, for this die, right? This is the die. So these are the various zones we are having here. Okay, so this is the deformation zone. ये जो दिख रहा है ये क्या है? This is the deformation zone. So say this is number 1. This is the sizing zone. Okay, this is the entry and this is the exit. Right. So entry is with the rod and output you will get the wire. Okay. So in the wire drawing process, dear students, so you can have A original by A final. That is nothing but the coefficient. Okay, coefficient of wire drawing. Or simply you can have the percentage reduction or maximum possible reduction in the wire drawing operation as A original minus A final divided by A original. Okay, this is, we can call it as a draft also, or coefficient of elongation also, you can say that. Now dear, there are the 2 cases that we have to understand. 2 cases. कौन से 2 cases? One is ideal case for force calculation. Okay, and there is a second case by considering friction and redundant work. If you consider friction and redundant work, Okay, so dear, in this case, in this ideal case of deformation, so this drawing stress we need to calculate first, that is sigma d is equal to sigma y, okay, into ln of this original area divided by final area. That is the drawing stress. This is the drawing stress in Newton per mm square. And now if you multiply with this drawing stress by the final cross section area of the wire, you will get the drawing load, wire drawing load you will get. Okay, so for final load calculation, you have to take this final cross section area, final cross section area, final cross section area of the wire, right? Or in case of the friction and redundant work, whenever the diangle is given to you, diangles are given to you, coefficient of friction is given to you. So in that case, dear students, the drawing stress is given as sigma d is equal to sigma y into bracket 1 plus b divided by b into bracket 1 minus final cross sectional area by original cross section area to the power b, where b is what? This mu into the cot of half the angle. This is actually 2 alpha. So half the angle will be alpha mu cot alpha. Okay, and of course again load calculation, load or force will be same, that is sigma d into final cross sectional area, that will be load in Newton. And anybody ask you power, calculate the power. So definitely if you have the product of force into velocity, force in Newton, you should take velocity in meter per second, you will get power as a watt, isn't it? I hope it is clear. So these are some of the very important formulas in case of the wire drawing operation. Wire drawing. Let us check it out the question. Yes. So in a wire drawing operation, the wire of diameter 5.2 millimeter is obtained. So D final is given 5.2 millimeter is obtained from 6 mm diameter rod. So original diameter is 6.0 mm. Okay. The included diangle is 18 degrees. So included diangle is given. So this is 18 degree they are saying. That is, this is a 2 alpha is equal to 18 degree. So alpha is equal to how much? 9 degree. Okay, isn't it? Now what they are saying, the coefficient of friction between the work and the die material. So mu is given as 0.15. Okay, then they are saying the yield strength of the material is 260 megapascal, right? Sigma y is equal to 260 megapascal. The mean stress of the drawing in the operation. What they are asking? The mean stress of the drawing. How to calculate mean stress? Just now I have given the formula. Sigma d is equal to sigma y into bracket 1 plus b upon b into bracket 1 minus a final divided by a original to the power b. Or you can write it, a final by a original is what? Pi by 4 d final square divided by pi by 4 d original square. So pi by 4 cancel out. You can write sigma d is equal to sigma y into bracket 1 plus b divided by b into bracket 1 minus d final divided by d original to the power 2 times b, because here square is there, right? So what is b here? Tell me. It is mu cot alpha. That is mu is how much? Mu in this question how much? 0.15. Cot alpha is what? 9 degree. Half the diangle how much? 9 degree. So Nikhil, so this formula, if they want to ask in 2018, they asked the question on this, definitely they have given the formula. They provided the formula in the question paper itself. Okay. So definitely it is not so difficult formula. Once you get the derivation of this, how it is come and how we derive this formula, then that is not a very big thing. So we will not have that fear how this difficult formula is there, right? We can very nicely derive this expression to calculate. Even we have not considered any back pull or push there. Okay, we are not sigma b pulling stress is not, we have not taken into account. So definitely we have assumed it is at 0. It is not mentioned. Okay, so it is very easy, no any difficulty. Okay, yes. So mu cot alpha. So b is how much? 0.947. Okay, 0.947. Now do the calculation. Drawing stress. Drawing stress is what? Sigma y is how much? Sigma y is 260. So sigma drawing is equal to 260, which is the sigma y, into bracket 1 plus b is how much? 0.947. Okay. So Nikhil, if you are preparing for GATE 2021, then I hope this is not the correct time to go for this derivation and all. Okay, if you are planning for 2022, then come on, join us. We will teaching you all these things. Okay, each and every derivation, how this each and every formula production engineering has come. Definitely, we are going to teach you. Okay, divided by b is how much? 0.947. Okay, into bracket 1 minus what is d final? D final is how much? D final, it is 5.2 divided by d original 6.0 to the power 2b into 0.94. So over, tell me the answer. Yes. So Nikhil, then concentrate on the formulas, on the practice of the numericals, how we are going to solve this. At this stage, that is not necessary. Truly speaking, it is not necessary. Yes, how much it is? 126. 126. Yes, dear students, how much it is? 126. Actually, it is 120. Yes, 127 megapascal. 127 megapascal. This is the sigma d. This is the sigma d. Okay. And for wire drawing and extrusion, formulas are same only. Formulas are same only. In wire drawing, what? We are pulling the wire. But in the extrusion, dear students, we are pushing the billet material. We are pushing the billet material. So that is only the difference, but all the rest of the things are same. So if this is a container, okay, if this is a container, it says direct extrusion. This is the billet material, and this is the ram which is providing the force. Okay, so definitely here in the wire drawing we are pulling the wire, but in extrusion we are applying the force on the billet. So direction of the force is get reversed only. That is the thing only. Formulas you can get same in case of the extrusion only. This sigma d drawing stress is equal to sigma y into bracket 1 plus b divided by b. Now because of change in the direction, you will get here a original by a final to the power b minus 1. Where you know that in extrusion process, original cross sectional area divided by final cross sectional area is known as extrusion ratio, is given by capital R. Extrusion ratio, capital R. Therefore, we can find this formula in the extrusion. In case of extrusion, it is nothing but sigma d is equal to sigma y into bracket 1 plus b divided by b into bracket r to the power b. R to the power b minus 1. And b, as it is, b is equal to mu cot alpha. Mu cot alpha. Because in extrusion also, see, this is the die. This is the die having this 2 alpha. 2 alpha is what? So this is the die again. 2 alpha is the complete or full diangle. Okay, I hope it is clear. So extrusion and wire drawing are the processes are same, even same derivation. Only the thing is that we have to change the direction of application of force. So from the on the raw material you are applying the force, it is the extrusion. And if already drawn wire you are pulling that wire, it is a wire drawing. Okay, so that is the reason why in the extrusion, when we calculate the force in extrusion, so now it is becomes the drawing stress sigma d into which area, which cross section area? Original cross section area. In case of wire drawing, so this is for extrusion. हम wire drawing में क्या लिखते हैं? We are writing the force in the wire drawing operation as sigma d into a final. So that is the change, you have to keep it in mind. So this change you have to keep it in mind. I hope it is clear. I hope it is clear. So wire drawing extrusion कोई फर्क नहीं, फर्क खाली डायरेक्शन का है, फोर्स डायरेक्शन का, राइट? I hope it is clear. Take the next question. Okay, so this is the question on forging operation, dear students. So forging operation. So dear students, ask your friends to join the session. Ask your friends to join the session. Very important, dear students. I hope this is useful to you guys for 2021, of course. Now see, in the case of in the case of forging operation, so this is the question on forging operation. What is there? A billet of 100 mm diameter. Initial diameter of the billet or raw material is how much? 100 mm, which is cylindrical there, right? And original height is how much? 50 mm. Now this height is reduced to 40 mm by the application of the moving platen, okay, or moving die. It is reduced to or deformed to 40 mm. So of course, if I take, this is the open die forging operation, this is the moving die, this is moving die, this is your cylindrical billet material is there, and this is the fixed die, right? And when you apply the force, definitely what is going to happen? The height goes on decreasing, whereas the diameter goes on increasing. Definitely volume constancy is valid. Volume constancy is valid. So if volume constancy valid, what I can write? The original area into original height of the billet material should be equal to final area and final height of the product, isn't it? Means what? If it is cylindrical, one cross sectional area is circular, that is pi by 4 d original square into h original is equal to pi by 4 d final square into h final. Pi by 4 cancel out. So I can write d final is equal to d original root over h original by h final. So see, this is the relation I can get for the height and diameter, isn't it? Now tell me, original diameter is with you, original height is with you, original or final height is with you. Only the unknown thing is right now at the initial talk, D final is not available. Calculate the D final. D final, tell me the D final will be how much? D original into root over H O by HF. H O by HF. So calculate D original how much? D original 100 into root over original height 50 and final height 40. Tell me the value of final diameter. Final diameter how much? So 5 divided by 4 root over answer into 100 into 100. It is 111.8 mm. 111.8 mm. Yes. Yes or no? Now I will tell you how to see. Read the question first. So 100 mm cylindrical billet diameter was there. It is get forced from 50 mm height to 40 mm height at 1000 degrees centigrade. The material have the constant flow stress is given 80 megapascal. Very nice. The flow stress of the material, see, constant flow stress is given 80 megapascal. So they are asking you to calculate the work done in the deformation, and after that they are saying if 10 kilonewton drop hammer is used to complete the reduction in one stroke or one blow, what will be the height of fall? Okay, so dear students, see, so whenever we are calculating, see, no any thing mentioned about the coefficient of friction. Okay, so whenever such a things are there or no any coefficient of friction is provided in the formula or in the forging operation, we need to calculate the force in the simple fashion. The force initial force, okay, which is minimum. F minimum initial you can calculate simply the flow stress or sigma y into original cross section area. Then you can find the F final minimum, okay, minimum, which is sigma y into A final. Simply you can calculate this minimum force, and from that you can calculate the average force required for doing the operation, which is F initial minimum plus F final minimum divided by 2. So once you get this force, average force, okay, now we can go on calculating the work done. And work done is what? Very easy. Force average, or if efficiency is given there, you can take the actual force. So, and into bracket the height displaced from or work done from 50 mm height to 40 mm. So H original minus H final. So tell me, what is F minimum initial in this case? What is sigma y? 80 megapascal into original area pi by 4. It was 100 mm. Okay. and then A final is how much? Because final diameter you got it as 1.8. So 80 into pi by 4, 111.8. Now tell me the value of initial minimum force, final minimum force. Okay, tell me. So it is 100 square into 0.25 pi into 80. So it is coming as 628.31, 628.31 kilonewton. Okay, then the minimum force at the final stage I am getting as 111.8 square into 0.25 pi into 80. I am getting as 785.3, 5 kilonewton. Please check it out. Check it out. Now take the average of this 628.31 plus 785.35 divided by 2. Divided by 2. Okay. So 628.31 plus 785.35 divided by 2. How much it is? I am getting force average at 706.83 kilonewton. Kilonewton. राइट सो ये मिल गया मुझे फोर्स एवरेज अगर मैं इसको डिवाइडेड बाय इफिशिएंसी कर दूं तो ये क्या आ जाएगा एक्चुअल आ जाएगा सो आई कैन राइट हियर एक्चुअल फोर्स सो हियर force is how much 706.83 it is kilonewton so into 10 to the power 3 into bracket this 50 original height minus height deformed to 40 of course these are in millimeters so I have to convert it into meter into 10 to the power minus 3. So tell me how much it is. Work done will be how much? So 706.83. 706.83 multiplied by 10. It will be 7068.3. It will be Newton meter. So it will be 7068.3 joules. Yes, 7068.3. I hope it is clear. Yes or no? Dear, please understand. ट्राई टू अंडरस्टैंड हाउ टू अप्लाई द फॉर्मूलीज ये फॉर्मूलीज कब अप्लाई करने के फोर्जिंग का अगर न्यूमेरिकल आए तो कि जब भी कोई कोएफिशिएंट ऑफ फ्रिक्शन नहीं दिया गया है ओके बट व्हेनेवर फ्रिक्शन इज देयर आई विल टेल यू व्हिच फॉर्मूला वी आर गोइंग टू यूज व्हेनेवर फ्रिक्शन इज देयर इन द क्वेश्चन and what they are asking the maximum force at the end of the stroke because there is a very important assumptions before analyzing this forging operation we are making that the maximum force will appear at the end of the stroke okay so please remember at the end of the stroke if they will ask the question and the coefficient of friction is given to you then how to calculate the force I will take the example I will tell you the formula what to do okay very nice now if 10 kilonewton drop hammer is used to have the same work done so this is the height of fall tell me how to get the height of fall so we know that work done in this case because there is an impact load this is the impact load we have to multiply by 2 times multiply by this 2 times what the weight of the hammer w into height so work done is how much here 7068.3 is equal to 2 into 10 into 10 to the power 3 because it is kilonewton into height h. Tell me how much height. Come on dear students, tell me how much height from which you have to fall that hammer. Yes, multiply by 2 impact loading or you can have this is gate applied the force is applied from these two surfaces. Okay, tell me what is the height through which the hammer should fall onto the workpiece. What they are asking the height of fall they are asking. If the same work done, we are going to use the impact load or that is the drop forging. We will be getting how much height is how much. Eight 7068.3 divided by 20 e to the power 3. 0.35 whether it is 0.35 0.35 it is meter. 0.35 it is 0.35 meter. Yes, please check it out whether it is okay. 0.35 meter. 0.35. अरे भाई है कि नहीं वहां पे कोई कैलकुलेट करने वाला? Sanur, hi. Please calculate. Yes, 0.35 meter is correct. 0.35 meter. Very good. Point. Can we go for the next question? So take it the next question, or I will tell you formula. And please make this note very important. Okay, how to calculate the force at the end of the stroke. At the end of the stroke. At the end of the stroke. Yes, Akhilesh, good. Okay, or at the end of the blow, at the end of the blow. Okay, how to calculate when mu is given to you, coefficient of friction. Okay, so in that case, dear students, we can calculate the force in the forging operation is equal to sigma y into final area. You see, maximum force is always taking place at the end of the forging operation. So please, so that is why I have taken here sigma y into AF. In addition to this only, the coefficient of friction is added here into bracket 1 plus 2 times mu RF, RF divided, which is D by 2. Yes or no? So use this formula, very important. Asking you to calculate the force at the end of the stroke, at the end of the stroke, which is maximum. Right? Clear? Yes, dear students. Am I audible and visible? Shall we go for the next? Now it is okay. Is it okay? Is it fine? Is it fine? Is it fine now? Please comment in the chat box. Tell me whether it is okay now. Am I audible and visible here? Am I audible and visible? So Imran, if you want to go for the forging analysis, definitely I can give you all the sliding and sticking length calculations. For not only simply for the slab, we can also have, this is for the disc also. So as far as see that part, you should consider in the ESE, okay, ESE examination, engineering services. So I hope that part is actually not applicable at that and at this time, of course. Then I will calculate the sticking length and then I will go and calculation the force Px into area. I hope it is okay now. So again, sticking length for what? For the slab, again for this for the disc. Okay. So come, definitely we can have all these derivations for these things. The load calculation in the forging. At this moment, this is not necessary. This is not required actually. So whatever required, I am trying to give you. So just have this. You will get benefited. Don't worry about it. Which branch? Mechanical or production? Imran? Okay, fine. Take the next question. Okay, take the next question and tell me the answer very fast. Come on, dear students. Join the session. Join the session. Concerned. See, this is again now it will go. The analysis will go into the slab. You are making the slab and you are making the disc, or you can forging the slab and you can forging the disc like that. So no need. Actually, this is no need. So till now you can see any question paper. If you are production engineering, definitely some of the chances are there because see they are having all the things. But as far as the mechanical engineering is concerned, till now, as far as my experience, my knowledge is best. So I have not seen any question paper. They are asking some the questions like on the sticking length and then calculation of the load. Okay, so definitely that kind of question we can expect in the ESE. Oh, and where it is in the conventional papers. Okay, so for the gate, that is more than, this is more than enough. See, this is more than enough. Okay, Imran. And if you see the previous year gate question papers on the forging maximum they are asking the strain in the operation. Simply they are asking the strain. Till now, if you go and see the previous year question papers, very rarely they are asking to calculate the force in the forging operation. Okay, then this without friction and with friction, this is a very long thing. Okay, they are simply giving you the initial diameter that much, initial height is this much, it is deformed to this height or this diameter. Okay, then what is the strain induced in the operation? Say simple things they are asking. You know how to calculate the true strain. Okay, you know how to calculate the true strain and all. So such a simple thing they are asking. You just see, don't trust me, you just have the look on the previous year papers. You will come to know about this forging, what actually they have asked till now, till in last 30 years. But yes, of course, in production engineering, if you go, there are having chances that they will ask some of the question from the sticking length. Okay, simply what they are again asking, they can ask the, see, the forces or the stress induced in the component. Okay, by the Tresca's condition or the von Mises condition, right? This is the Px, this is the force Px, then this will be how much? The friction force mu Px. So like that simple analysis that we have, they can able to ask. And you know that in the forging operation, definitely the stress is going to be compressive. Okay, so one question was there in, I hope in 2018 was that. So minus sign should be there. So sigma x plus Px, you know that formula, sigma x plus Px is equal to what? It is sigma y. Okay, so sigma x will be y, sigma y minus px. Right, so this is the expression we can very nicely take from the von Mises condition or the Tresca's condition, and they are coming to the same results when we are considering the spherical coordinate system. So again, that detail I don't want to go. It is very, again, I can go inside that subject. But at the moment, you just have the formula and solve the question. Okay, for that we'll plan something new, analysis and all. But you should be there. Okay. In wire drawing operation, see here, this is the ideal case of deformation. So no any friction and all. Simply you can have the drawing stress is equal to what? What? That is sigma y, yield strength of the material, into ln of A original divided by A final. Isn't it? Very simple. So tell me what is A original? That is sigma y into ln of D original by D final to the power 2b, to the power 2b. Isn't it? Then tell me what is the sigma y? Sigma y is 280 into ln of D original. Sorry, only square. There is no any friction. No, so no any b. No any b. Only 2. So ln of D original is how much? 10 divided by 4 square. So tell me how much it is. The drawing stress will be how much? So 280 into ln of 10 by 4 whole square. 10 by 4 whole square. Ln of answer into 280. So how much the force you are getting here? So sigma D, how much you are getting sigma D? Is that 513.12 megapascal? And force will be how much? This sigma D into final area. So sigma D 513.12 into pi by 4. D final is how much? 4 square. Into 0.25 pi into 60. So please tell me whether it is correct or wrong. Is that okay? Yes, Girish Mohanty. Yesterday also I have sent the PDF to that. Our group, see the link. See in the comment box. See in the comment, there is a group. Telegram group is there. In that yesterday I have already given the PDF. Yesterday's session PDF is there. Tell me how much it is. 513 is correct. PDF just given, the link is given there for the Telegram channel where we are going to put the PDF after just finishing of the class. Just finishing of the session, I will be putting PDF there. You take it, right? Yesterday's PDF is already placed there in the Telegram channel. Telegram group is there. Okay, so 513 is correct. Then what is force? So I hope then the option I have to change. Tell me 513.12. Then what is the force? Final area 6.4. Okay, I will take 6.4 definitely. On that basis we have to change the option. 6.4 is absolutely correct. Okay, Neeraj, very good, Neeraj. So 6.4 kilonewton, no? Okay, so 6.4 kilonewton, that is 10 to the power 3 Newton. This is the force in the drawing operation. It is an ideal condition. No any friction and all. So tell me what is power? Sir, final area, wire drawing operation, dear. Wire drawing operation, I already told you the input is a rod. The input is rod and output through the deformation after the die you are getting as the diameter of wire. This is the D final. This is the D original. Okay, and we are applying the force here at the end when wire is come out from the die. We are pulling that wire. We are pulling that wire. So this is the pulling force. That force is pulling force. Okay, so tensile loading is there onto the wire. So this pi by 4 D final you have to take. In case of extrusion, you take it at the back side of the die and take the original area for the calculation of the load. I already told you. So here 6.4 into 10 to the power 3 into final cross sectional area pi by 4. D final is how much? 4 square. Tell me how much it is. So 4 cancel out. Tell me. So 6.4 e to the power 3 into pi. How much it is? Into velocity. Power is what? Force. So see. Oh my god. Oh my god. Already we calculated the force. So because of you, I see. Once again, I am going to calculate the. I want the power now. See, force is okay. Force is 6.4 kilonewton. Then say velocity is how much? Drawing velocity, drawing speed is given 80 meter per minute. So I can write the power is equal to. I can write power is equal to what? The force into velocity. Force into velocity. Force is 6.4 into 10 to the power 3 into velocity 80 meter. Okay, meter per minute, that is divided by 60. So it will come as Newton meter per second, which is nothing but what? Tell me, is 8.5 is correct? Okay, 8.5 kilowatt. 8.5 kilowatt, this is the power. Very nice, very nice. Suppose anybody asks you what is the maximum possible reduction in area, maximum possible reduction in the ideal case of deformation. What is the maximum possible deformation you can get in the wire drawing operation? If anybody asks you what is the maximum possible deformation can be obtained in the wire drawing operation in the ideal case. So you know that how to calculate the maximum possible reduction in the area. A original minus A final divided by A original into 100. That you know. That means 1 minus A final divided by A original into 100. This is the maximum possible reduction. Now dear students, for the ideal condition, you know that the drawing stress is equal to sigma y into natural log of A original by A final. And what for the maximum possible reduction, what I am assuming that whatever the yield strength of the material and the drawing stress are get to be same, then I can get the maximum possible reduction, isn't it? So definitely if the sigma d, definitely this value something is there. So of course then definitely this value sigma d is higher than the sigma y. But I am coming to the one stage where I can have the whatever the sigma d is nothing but the yield strength of the material. These two are equal, I am assuming or getting for maximum possible condition, maximum possible reduction. That is sigma d divided by sigma y is equal to 1. That is 1 is equal to ln of A original by A final, isn't it? That is e to the power 1. Take the antilog, which is nothing but A original by A final. Or here what I want A final divided by A original as 1 upon E. Put the value of this A final divided by A original here. I will get 1 minus 1 upon E into 100. Tell me how much? Tell me how much? Sittimar production, what you want? Tell me how much is the maximum possible reduction in the area in case of ideal case of deformation, no any friction, no any redundant work. Even if you consider the friction and redundant work also, this condition is not going to change. Sigma d, at least the sigma yield and sigma d drawing stress and the yield stress are to be the same, then you can go for maximum possible reduction in area. Are batao to sahi bhai, how much is the answer? So 1 upon E. So 1 minus 1 upon E. Yes, 63%. Yes, dear students, please remember. In case of the wire drawing operation, anybody ask you what is the maximum possible reduction in case of the ideal case of deformation, it is 63%. Yes, 63%. That is clear. Excellent. And if I say this is the tube drawing operation, if this is a tube drawing operation, dear students, see, we are trying to cover your some small concepts also. So tube drawing operation where the same thing like a wire drawing operation, but here we are going to go for sizing of the tube. So this is the initial thickness of the tube. This is the final thickness of the tube that we are going to get after, say, passing on through the, say, mandrel, okay, whatever it may be. Now tell me how we are getting. So this is the original thickness HF, HO, final thickness HF. So what is the maximum possible reduction? H original minus H final divided by H original into 100. Because thickness in the tube drawing process, we are just sizing the thickness. We are not producing the new tube. We are just sizing the tube which is already produced by some other process. That is a tube drawing operation. And very important thing is that, dear student, the tube drawing operation is what? It is the plane strain condition operation. That thing we have to keep it in mind, where sigma y will be replaced by sigma y dash, which is equal to 2 by root 3 times sigma y. Okay, please understand this. There are very few operations. We are assuming that rolling operation is one of the plane strain condition operation, where no spreading of the width, no spreading of the sheet along the widthwise direction. Then this tube drawing operation also a plane strain condition operation, where sigma y will be replaced by sigma y dash, which is equal to 1.15 times of sigma y. You know that. Now here, if anybody asks you what is the maximum possible reduction in case of the tube drawing operation, same in the ideal case of deformation I am asking. So definitely it will be sigma d into ln of h original by h final. That is the, sorry, sigma y into sigma y will be replaced by the sigma y dash. The drawing stress, I will write here once again, drawing stress in the tube drawing operation, tube drawing, same like y drawing operation, which is equal to sigma y dash. Y dash will be there because it is a plane strain condition operation into ln of h original by h final. Okay. Analysis, while during the analysis, we are not assuming that this is a plane strain condition operation. Please. For analysis, we are tube drawing operation. We are considering the original thickness and final thickness. I hope you have not gone through the analysis of all the processes. Please understand this. So tell me, sigma y will be how much? Sigma y dash will be how much? 2 by root 3 times sigma y. Okay, ln of h original by h final. This is the sigma d. And for the ideal case of deformation, sigma d is equal to sigma y. Okay, so sigma d and sigma y are same, cancel out. So root 3 by 2 is equal to ln of h original by h final, isn't it? So e to the power root 3 by 2 taking anti-log is equal to h original by h final. Yes or no? And what is maximum possible reduction? H original minus h final divided by h original into 100, which is equal to 1 minus h final divided by h original, which is equal to 1 minus 1 upon h original by h final, which is how much? 1 minus 1 upon h original by h final, which is e to the power root 3 by 2. E to the power root 3 by 2. Tell me, into, don't forget, into, there is a percentage 100. Tell me, so in the ideal case of deformation, when we talk about the tube drawing operation, please. So how much tube drawing operation, how much you can go for the maximum possible deformation? Please tell me the value. Tell me. So see in the bulk deformation, yes, that is 57.93 means how much? 58%. How much? 58%. Please remember, this is the maximum possible deformation in the tube drawing operation. In the tube drawing operation, maximum possible deformation is 58%. In the wire drawing operation, maximum possible deformation, we have not considered Dharni Krishnan, we have not taken sigma y as a sigma y dash in case of the wire drawing operation. We are not assuming it is a plane strain condition operation. Not requirement. But here tube drawing operation, this is a plane straight, right? 58%, that is the correct answer. 58%. See, tube drawing maximum possible deformation with the ideal case 58%. Why with the maximum possible reduction in the ideal case of deformation 63%. 63%. I hope it is clear. Very nice, very nice. Take the next question. This is the question. Very nice question. Understand this question. Estimate the force required to upset. Upset मतलब upset करना है. Forging का सबसे simple तरीका upsetting. Between two open dies, one is moving, other is stationary. Yes, yes, Sidhu. I am telling you the same, dear. While doing the analysis, tell me when you are coming to the entire theoretical part of this conventional part of ESE, we need to derive all these expressions. For wire drawing, tube drawing, extrusion, forging, whatever the bulk lever, rolling, all the things. So when you go and learn and read that part, definitely will come to understand. At this moment, so it is not the right platform actually, because this is not a simple 4 or 5 minute discussion. It is a long discussion here. Yes, plane strain condition, it is very important for the tube drawing operation. We are, this plane strain condition is valid there. Take this question. I already discussed the formula for this. Estimate the force required to upset 2 mm diameter brass rivet in order to form the head of 5 mm diameter and 3 mm thick. Assume that the coefficient friction between the brass and the tool steel die is 0.1. Take average flow stress of the material 100 megapascal. So see, estimate the force required to upset this rivet. Calculate. So initial diameter D original of the head is how much? 5 mm. Okay. How much it is thick? Height is given. So upset कहाँ पे करना है? 2 mm पे करना है. D final is equal to 2 mm. Okay. And thickness H final कितना करना है आपको? Estimate the force required to upset 2 mm diameter brass rivet in order to form the head of. So initial diameter is 2 mm. Final diameter is 5 mm. And final height is 3 mm. Okay. Very nice. Others, very good. Now check it out. Coefficient of friction mu is equal to 0.1. The flow stress is how much? 100 megapascal. Okay. Now calculate the original and final diameter you required. So final height is there. Very nice. So what is formula actually? Force is equal to sigma y into AF into bracket 1 plus 2 mu RF divided by 3 times HF. Yes, sigma y is how much? 100. A final pi by 4. D final square. Okay. Sigma y is 100 into pi by 4. Tyagi. Good evening. Why your message is head for the review? Tyagi. Pi by 4. D final is how much? Final diameter from 2 mm to 5 mm. You are going to expand. When you see, when there is a head and when you apply the force, okay, we are making the rivet, so you are getting the diameter after this as a 5 mm, right? So pi by 4 diameter is how much? Cross section is 5 square into bracket 1 plus 2 times mu is how much? 0.1. R final 2.5 divided by 3 times H final is how much? 3 mm. So how much it is? Is it 2.07 kilonewton or 2 kilonewton? Is that 2 kilonewton, dear students? 2 kilonewton, nearly equal to 2 kilonewton. Yes, this is the force. So to make this rivet, dear, how much force we need to apply? Are bhai, anybody else is there who is calculating? Yes, 2 kilonewton. Sidhu, very good. Anybody else? Others, very good. It is 2 kilonewton, dear. Akhilesh, very good, very good. Excellent, excellent. Very nice, very nice. Come on, dear students. So, which topic you want after this completion of this series? Tell me which topic do you want for this marathon, so that we can have that topic and entirely we will go and solve all the questions related to that topic. Yes, Krishnan, very good. 2 kilonewton, very nice, very nice. Please comment in the chat box. Comment in the chat box what you want. What do you want? Whenever Taggy's message come, there is a message which is held for the review. Why, Taggy? I don't know why you are doing like this. Very nice. Metal cut. Yes, speak out, speak out, speak out. अरे बोलो भैया कौन सा, मेरे को और एक मैं सेशन लेने वाला हूं और एक टॉपिक कंप्लीट करूंगा आपके लिए. नाउ metallurgy and material science marathon, it will be the pure theoretical one. There are, yes, volume phase fraction calculation numericals are there, but only that part is there. So welding and metal cutting. So see, select the topic such as that which can have the very high weightage. So see, metal forming is one of that. Metal forming including sheet metal, we can go up to the 4 to 5 marks. And after that, the only topic left, dear students, metal cutting. See, directly they are asking the numericals. Tack. Take these 3 numericals, 6 marks. Take it out. So like that. So every year you can go just see the previous year question papers. Metal cutting is very important. So please write your opinion. There are so many people are there. Everyone should write. Everyone should write their in topic area of interest, which topic they want. So that definitely I will plan. Casting is already completed in the, see, casting technology, welding technology, all the things I have already completed in the crash course. जो शाम को 7 बजे होता था 7 to 8 PM में, every day I have taken the numericals on that crash course. Now these are the, see, marathon series. Metrology is the left over, that I'm going to complete it. So this is the metal cutting American Standards Association, ASA, and orthogonal rake system. So these are the tool signatures you are talking, Adarsh. Yes. So once you come in metal cutting, definitely we are going. So shall I finalize that topic, metal cutting? Please. So on this basis only I will plan for my upcoming series. Let me know metal cutting final करना है या नहीं करना है भाई, या फ्लूइड मैकेनिक्स कुछ ले लूं. Take this question and now tell me, calculate the number of passes to draw this wire. Calculate the number of passes to draw the wire. Calculate. So actually see, this metal forming we have seen in depth actually yesterday, all the fundamental things, today all the bulk deformation processes, right? Okay, production is final. So metal cutting, the next topic, metal cutting. So again, like this, 2 days we'll be having the session, we'll be having the marathon series for 2 days. Metal cutting final, done. Final, it is done. And do follow me on the Gradeup app. Do follow me on the Gradeup app. There are so many free series going on. Right now there is a welding going on. Today also I have the welding session there. Tomorrow also I am having the welding session. So join that also. Now take this question. In a wire drawing operation, diameter 7.2 millimeter is reduced in the number of stages to draw 2.64 mm. So original diameter was say 7.2 millimeter, and it is after passing through the number of stages, it come to the 2.64 millimeter. In the operation, half the diagonal, that is alpha, is given as 9 degree and coefficient of friction given as 0.2. The average flow stress is given as 85 megapascal. Calculate the minimum number of passes required to draw this operation. So that will be in January, dear captain. So yes, that thing is definitely decided already. In January we will be planning for that formulae, the series for the formulas revision, right? So formulas, all the production engineering formulas, and for that particular formula, one example like that I am going to have the sessions already planned, series is already planned. So I hope join our say new channel for the mechanical engineers. Every day midnight series is actually running on that at 11 p.m. Okay, so mechanical marvels. So this is a new YouTube channel. This is already launched, dear students. Subscribe that channel and be there every day at 11 p.m. So it is started already, and in that particular what we plan, that is a formula series along with the questions. So it will be in January. But I am talking about the December only. So one more topic I am going to cover before December ends. And of course, this will be upcoming Monday and Tuesday. I am planning to have that series on the metal cutting. Yes, tell me, calculate the minimum number of passes. Okay, how to solve this question? Let us see here. All the people, please look at here. You know that the sigma d drawing stress is equal to what? Sigma y into bracket 1 plus b divided by b into bracket 1 minus a final divided by a original to the power b. Okay, and for this case definitely, dear students, they will be given you what? The case or condition that the maximum possible reduction that you want, and for that only you are eager to find out the number of passes. For what? Of course, for maximum possible reduction. For maximum possible reduction. Definitely it will given to you. Don't worry about this. Okay. So by default you have to assume that, then and then only you can go for the C, minimum number of passes when you will be having maximum possible deformation. That is very simple thing. Now you know that for the maximum possible reduction, to get the minimum passes, you should get the sigma d and sigma y are same. Okay, that is nothing but the maximum possible reduction case. So I will write here 1 is equal to 1 plus b over b into bracket 1 minus d final divided by d original to the power 2b. That you know very well. Now here b is equal to what? Mu cot alpha. Mu cot alpha. Tell me value of mu cot alpha. Mu is 0.2 cot 9. 0.2 cot 9. B is how much? B is how much? 0.2 divided by tan of 9. It will be 1 point. How much it is? Is it 1.26? Is it 1.26? Okay. 1.26. Okay. Right. Now, yes, that is correct. Now, dear students, I want the ratio of what? D final by D original. So, can I get here? So, I will write here B divided by 1 plus B is equal to 1 minus DF divided by D original to the power 2 into 1.26. So tell me B is what? 1.26 divided by 1 plus 1.26 is equal to 1 minus DF by DO to the power how much? It is 2.52, right? So 1.26 divided by 2.26 is how much? 0.55. So 0.55 is equal to 1 minus df by do to the power 3.5. So tell me here d final divided by d original to the power 3.52 is equal to what? 1 minus 0.55. So 1 minus answer. Okay. So it will be df divided by do is equal to this what? 0.44 to the power 1 upon this 3.5. So how much? 0.1 upon 1 upon 3.52, that is 0.4424 to the power answer. So it is nothing but d final is equal to 0.8 times d original. So this is the ratio we are getting here. Okay, please check it out. Yes, very good. Now tell me, you get the ratio as d final divided by d original is equal to 0.7931. 7931. That is actually correct answer. Okay. Oh, this is 2.5. 2.5. Okay. 2.5. So 1 upon, so d final divided by d original is equal to what is there? 1 minus 0.55. I will write 0.45 to the power 1 upon 2.5. So d final by d original, you can get it as 0.728. Okay. So now this is the, see, you get this ratio d final by d original. Now what is the original diameter? If you want to find out the number of passes, see, original diameter is how much? 7.2. You want the final diameter 2.64. Okay. Original diameter is 7.2. Okay, chalo, pehla pass lete. Are you ready? So I will take the first pass. Take the first pass. So in the first pass, final diameter will be the first diameter, and original diameter now is known to you. How much it is? Original diameter d original kitna hai bhai? 7.2 millimeter. Okay, take the diameter. So d1 will be equal to 0.728 into 7.2 into 7.2. Check it out. So in the first pass, dear, we will be getting the diameter 5.24 millimeter. But how much you require at the final stage? you require the final diameter 2.64. So definitely it is very huge from or greater than 2.64. So this is the pass number 1. Go for the another pass because it is bigger than 2.64. Just go for the second pass. So D2 will be how much? D2. So D2 will be how much? This D1 into ratio is how much? 0.728, 0.728. So D1 is how much? पहले पास का कितना था? 2.4245 into 0.728. So how much? In the second pass, into 0.728. How much it is? So it is 3.18. So 3.818 mm, which is again greater than 2.64. Yes, 2.64 से क्या है ये bigger है definitely. Now we have to go for the some next pass. So 2 pass already done. Get the third pass which is equal to again 3.1818 into 0.728. Tell me how much? Into 0.728, how much? It is 2.78. It is 2.78, which is again bigger than 2.64. So third pass completed. Go for the fourth pass. You will get D4 is equal to this 2.78 into 0.728. Check it out. Into 2 into 0.728. How much it is? Yes, it is 2.02, which is less than or equal to 2.64. चलेगा भाई. So fourth pass लगेगा. You need the fourth pass when you need to draw the wire from 7.2 millimeter diameter rod to the 2.64 millimeter wire diameter. You need to have how many number of passes? 4 number of passes. 4 number of passes with the given data, of operation. I hope it is clear. I hope it is clear. So 4 passes लगेंगे भाई, 4 passes. That is clear. Take the next question. Tube drawing जल्दी से निकाल. Tube drawing का question आया सामने. In a tube drawing operation using plug for the purpose, mandrel for the purpose, you can say mandrel plug. Okay. The final diameter of the tube 10 millimeter obtained with the inside diameter 7 mm. The drawing stress is 850 megapascal. Drawing stress is already given. Sigma D is given. How much? 850 megapascal directly given. And what is there? Yes, that round up to the fourth pass. Definitely you should go for the fourth pass. And what is the speed of drawing? Speed of drawing, it is 0.6 meter per second. Okay. Yes, okay. Calculate. How to calculate the force in the wire tube drawing operation? So force in the tube drawing is nothing but sigma D into pi by 4. Okay. Into diameter, outer diameter square minus inner diameter square. So see when the tube will come here at the end. So with the some thickness, final thickness. So this will be outer diameter and this will be inner diameter. Okay. So final diameter of the tube. See this is final, not final. This is the outer diameter is given. Outer diameter is 10 mm and inner diameter, inside diameter is 7 mm. Okay. Sigma D is also given. It is 850 into pi by 4 into bracket D original 10. D outer is 10 millimeter, 10 square minus inside 7 square. So this is the force in Newton. Force in Newton. This is the force. This is the stress, drawing stress into this area, cross section, final cross section area. You will be getting as the force. Tell me. Tell me. That was a very nice question. Yes. Very nice question. Yes. Tell me the value for this. Tell me the value for this. That is 100 minus 49 into 2.25 pi into 850. So it is coming as 3.4047. 3.4047. This is kilonewton. This is the force. And power will be what? The force into velocity. Force is 3.4047 into velocity is how much? The speed of drawing 0.6. 0.6. Definitely it is kilonewton, so power will be in kilowatt. How much? Into 0.6. It is how much? 202.8.20 kilowatt. I hope it is clear. Oh, it is 3.4047. Please check it out. Please check it out the calculation. So force is how much? 3.40 or 30.34 point. टेल मी द आंसर भाई, बताओ जल्दी से एग्जैक्टली सही क्या है. हाउ मच किलो न्यूटन? It is 34.47 kilonewton. Yes, 34.047 kilonewton. Right, this is the force. Now what is power? Force into velocity. Force is 34.047, okay, into 10 to the power 3 and into 0.6. How much? Yes, that is correct, Akhilesh. So into 0.6. So it will be 20428.20 watt. They are asking in the horsepower. They are asking in the horsepower. See, the power rating of the motor in horsepower. In horsepower. So you know that. So it is not kilowatt, Akhilesh. It will be 20428.20 watt only. Because see, it is not kilowatt. Yes, yes, that is correct. Now see it here. Convert this horsepower, convert this watt into horsepower. That is, if I divide it by 746, okay, divided by 746, so it will be around 27.38 horsepower. Is that okay? Yes. Is it okay? So 27.38 horsepower, because 1 horsepower is equal to 746 watt. 746 watt. एक अश्व शक्ति ये कितने वॉट के बराबर होती है? 746. यस, आई होप इट इज क्लियर. Take this question on the extrusion. If the extrusion ratio is 20, percentage reduction in cross section of the billet after extrusion will be. Take this question. If the extrusion ratio R is given, it's 20. The percentage reduction in cross section, that is A original minus A final divided by A original will be how much? And of course it is percent into 100 karna padega, isn't it? Tell me. So we know that sigma is equal to what? Sigma y ln of r, isn't it? So how much it is? कितना आएगा भाई, बताओ जल्दी. So R is given A original by A final. How much? So see here, extrusion जैसे R is equal to what? A original by A final, which is equal to how much? It is given as 20. Okay, and you know percentage reduction, how to calculate? परसेंटेज रिडक्शन कैसे निकालते हैं? ए ओरिजिनल माइनस ए फाइनल डिवाइडेड बाय ए ओरिजिनल. Okay, so 1 minus a final divided by a original, which is nothing but 1 minus 1 upon 20 into 100 into 100. So 1 upon 20, 1 minus answer into 100. So how much it is? 95%. 95%. So yes, B is the correct answer. B Bombay is the correct answer. 95%. Is that okay? 95%. Take the next question. Using direct extrusion, a rod billet 200 mm length and 75 mm in diameter is extruded considering the ideal case of deformation. See, ideal case of deformation. Ideal case of deformation. In extrusion, same way, in the same fashion as we done in the wire drawing operation, that is sigma D is equal to sigma Y ln of A original by A final. But here A original by A final क्या होता है extrusion में? Sigma Y ln of R, extrusion ratio. So tell me sigma D will be how much? Sigma Y is how much? 400 into ln of extrusion ratio 4. So what will be the drawing stress in the extrusion? So 400 into ln of 4, that will be 554. Sigma D how much? 554.51 megapascal. This is the drawing stress in the extrusion. And now what is the force? I told you sigma D into which area will take? A original area, that is 554.51 into pi by 4 original billet diameter 200 length and 75 mm diameter. So into 75 square. Tell me what is the force? So that will be okay when we are talking about the forging operation, wire drawing operation. So this is nothing else. See, ln of A original by A final is, this is the strain only. This is the strain only. That is correct. Yes. So initial length 200. You can get, you see from the volume constancy, you can get the final length. Okay. That is also done. Yes. See, in all the metal forming operations, volume constancy is valid. So how much it is? 2.4 meganewton, 2.45 meganewton, 2.4 meganewton, 2.4 meganewton. Right. Absolutely correct. Very good. See, ideal case of deformation. Ideal case, sigma Y ln of R. This is the drawing stress. Or see, sometimes very standard formula according to the Kalpak-Jian, it is given as the force in the extrusion force. F is what? Extrusion force. Extrusion force. If you read the Kalpak-Jian book, okay, it is given as Ka naught ln of R. Okay, Ka naught ln of R. This is the force you can find. Ka naught ln, where K is what? Extrusion constant. Sometimes in the question they will provide you the value of constant, which is nothing but yield strength only. Sigma Y ln of R. ये क्या हो गया अपना? अभी just निकाला sigma D into A naught. A naught is what? Original area. The same thing that we have done. Only the writing is somewhat different. No any difference. K is what? Extrusion constant, which is nothing but sigma Y, yield strength of the material. Don't worry. Or the flow stress of the material. Don't worry. Okay. So in this fashion also we can write the formula A naught ln of R. This is also the load calculation formula for rolling operation. I hope it is clear. आई होप इट इज क्लियर। अरे बताओ भाई जल्दी, है कि नहीं क्लियर? देखो रोलिंग देख लिया, वायर ड्राइंग देख लिया, ट्यूब ड्राइंग भी देख लिया, अभी एक्सट्रूजन आज चल रहा है, एक्सट्रूजन चल रहा है, एक्सट्रूजन। अरे भाई बताओ तो सही, सही जा रहा है कि नहीं, समझ में आ रहा है कि नहीं कुछ? आर यू गेटिंग द थिंग्स प्रॉपरली और नॉट? So see, at this moment, even you are very clear with the formulas, what is in the formula and how to use that formula. That is more than enough. So don't forget the next topic will be metal cutting. Do follow me on the Gradeup app so that I will announce there. I will put information there. You will get notification. So do follow me on the Gradeup app. Do follow me on the Gradeup app. Okay, so that you will get notified when I am planning the series. Shiv Hare, Adarsh Shiv Hare, very good dear. Nice. Next question. Take the next question. This is from the punching or sheet metal working, rather. I would say sheet metal working. So before that, just you take this question for the homework. Don't worry about that. So washer outer diameter is there, inner diameter is there. Outer diameter 44, inner diameter 22. You know how to do that. Pi d1 t tau s, okay, plus pi d2 t tau s. You can add these two forces, you will get the maximum force. Work done is what? F max into kt. You will get the work done, okay. And this is very simple. This is very simple, okay. So shall we solve this question here? Okay, let us solve this question. So steel washer of outside diameter, washer is there, one washer is there, okay. Outside diameter d outside 44 mm and inside diameter say 22 mm. And you know that by default whenever the washer is there, by default it is made by the compound die, okay. So at a one stroke, more than two operations of the cutting you can get only in case of the which compound die. So thickness of the sheet is how much? It is 12 mm. So definitely shear stress 405 megapascal is given. So how to calculate the load? So load or force will be pi d1 plus d2 into t into tau. Pi dt tau, yes, we know that. So outer diameter, inside diameter, that we have to take addition because at a time they are going to made. So pi into d outer 44 plus d inner 22 into thickness 12 mm, 12 into shear strength 405. This is the force F max in the punching or blinding. Tell me 44 plus 22 into pi into 12 into 405. How much? I am getting here 1007. Please tell me whether it is correct. How much? It is 1007.7. Okay. Kilonewton. It is kilonewton. This is F max. And work done, you know, work done is what? Force into displacement, F max into KT. K what? KT is penetration. K is penetration, T is the thickness. So F max is 1007.7 into 10 to the power 3 into penetration is how much? It is 24% into thickness. I hope something is wrong there. It is 12 mm thick is not there. Please, it is 1.2 mm thick. So it is a sheet actually. See, this is a sheet. 1.2 mm thick sheet is there. 1.2 mm thick sheet. So point, it is missing here. So it is 1.2 mm. So it is 1.2 mm. So tell me what is the change is there. How much it is work done now? Force is how much now? It is 100.8. It is 100.8 kilonewton. 100.8 kilonewton. So this is 100.8 kilonewton into 10 to the power 3, that is into 24% into thickness 1 point. Tell me, now tell me, into 0.24 into 1 point. So this will be how much? 29 kilonewton. Yes, 29.02 kilonewton meter. That is nothing but 29.02 kilojoule. Yes, that is, of course, that is correct. That is correct. Yes, very good, very good. So see, 12 mm, it's very huge thickness, yeah. 1.2 centimeter of washer, it is not possible actually. This is a sheet metal working. 1.2 mm, that's okay. That is practical thing. Yes, yes, excellent, 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 dear students. Very good, dear students, very good. So take this leftover questions, very easy, as a homework. So yes, there are the two questions based on the deep drawing operation. Deep drawing, yes, it is there. So blank size calculation, you know very well, I hope. So I will stop the today's session. I will wind up the today's session here only. Okay. So dear students, yes, yes, that is the thing why I changed that. I realized that it is not the sheet, no more sheet, it is a plate. Right? Yes, less than 6 millimeter we are called it as a sheet. Yes, correct, correct, correct. Krishna, Krishna, that is correct, Krishna. Dharni Krishna, very good. So I will keep these questions as a homework. Okay. Try to solve this question and hope you understand whatever the today's session we had, whatever the thing we discussed is now okay with you. Thank you so much, dear students. Please see, look at here. If you are right now in the second and third year, definitely this is the Vision 2022 is a very excellent course, right? So you can see the course details. No one in the market is going with this much kind of the live hours, right? 950 plus live hours, and it is online. Okay, so it is used, dear students. Very ideal course for the second and third year. Any query you can contact on the given number. These are our faculties, these are our achievers. This is the pricing for the subscription Gradeup Super. Any query you can contact on the given number. So next series definitely I will plan it for the metal cutting. For that, do join me on the Gradeup app. Join me on the Gradeup app, dear students, so that you will get notified first, right? And like this session, share this session among your friends on the social media platform. Also, you can share this information. Thank you so much and all the best. Take care. Bye bye. Have a good day.